Hospitals are buildings which consume enormous amounts of energy, up to 2.5 times more than offices. They are open 24/7 and operate 24/7. In the EU, there are some 15,000 hospitals responsible for at least 5% of the annual EU's carbon emissions. Designing hospitals is a complex task. There are many requirements from different stakeholders, and there are many technical options for the mechanical, electrical, and plumbing, or MEP technologies. The challenge is to design a hospital that satisfies all these conditions and is as energy efficient as possible. Usually, the hospital functions are separated. There is the hot floor, where medical processes take place. There are the offices, where administration is done. Patients stay in the hotel area, and there are a large set of so-called industry functions that support the building. Each function has its own technical characteristics and requirements. At the start of the design process, the client formulates the project requirements, including the description of the number and area of each different type of space. In the streamer methodology, these requirements are enriched with labels that attach specific properties, like performance level to each type of space. Normally, it is costly and time-consuming to create different designs. Using the Streamer Early Design Configurator tool, it is easy to create different layouts. Each of these early designs can be evaluated, so the best variant can be chosen. The Early Design Configurator generates possible design layouts that satisfy the program of requirements. This tool also takes into account a set of design rules that represent the experience from the design team. For instance, a design rule may constrain some types of rooms to be clustered on the same floor. The designer is able to define the building envelope and fixed building elements within the Early Design Configurator. The Early Design Configurator continuously tries to find the optimal spatial configuration until the end user is satisfied with the proposals and stops it. A building information model is generated for each best design configuration, found by the Early Design Configurator. Each alternative can then be used as a basis for further design. The building energy performance is influenced by the choice of technologies for building envelope and the mechanical, electrical, and plumbing systems. Some labels that are defined in the program of requirements, like the hygienic class, are used by the Early Design Configurator to filter acceptable MEP systems for each space. Using this information, the engineering team can select a common MEP system for each identified group of spaces. Several options can be studied in parallel. Energy simulation tools can be used to evaluate the energy demand or the energy consumption of the hospital at an early and coarse design stage, where normally energy simulation is not possible yet. The streamer semantic labels are also used here. The labels are linked to default values that provide a good estimate of the practical situation. This information is used by energy simulation tools, which calculate the estimated energy demand of the design alternative. When the energy demand of each design alternative has been calculated, the assessment can be finalized by using a multi-criteria analysis. Besides energy, also life cycle costs and quality parameters of the building are taken into account. A decision support tool includes assessment modules that allow calculating these indicators. Eventually, several design alternatives can be compared through a user-friendly interface, showing results through meters and graphs. We have now created different design alternatives. The building envelope and MEP technologies have been selected, and we have been able to calculate the energy demand for each alternative. That one alternative which is chosen to be the best outcome is clearly performing better and fitting better to requirements of the client, because more aspects and more alternatives were taken into consideration in the design process. Streamer helps designers and other professionals and stakeholders to quickly define, assess, and compare several design alternatives at the earliest stages of the design process. Streamer enhances the state-of-the-art design process with methods and tools that help to create results that are optimized in energy, cost, and quality. STREAMER is a European research and development project on energy-efficient healthcare districts. The aim of the project is to develop design methodologies and computer-aided design tools for development of operationally economic energy-efficient healthcare districts (HCD), integrated with neighborhood technical infrastructure, guaranteeing energy and media supply safety for hospital campuses (HCS). The project team of specialists consists of 19 partners, 5 IND plus 6 SME plus 4 PUB plus 4 RES Form, 9 EU member states from 5 regions of Europe, as indicated below in the table. The project is co-financed by the European Commission under the 7th Research Framework Programme FP7 for research, technological development and demonstration under Grant Agreement number 608739.